March. मैंने सर्वे को मैंने पूछा था कि कब से क्लास तो फिर देखिए कि कल से लेकर 4 बजे इसलिए मुझे 4 बजे मैंने पूछा कि और पूरा उधर ही रहने का मैंने बोला कि कभी नहीं कर सकते तो मैं से लेकर 4 बजे किसकी वजह क्लास के लिए फिर वापस बोला कि वही हुआ हमारी क्लास हाँ पहले मैसेज किया था वही जो कोई ऐसा अच्छा वही होगा तो मुझे तो करने लगती से मुझे क्लास के बाद टेस्ट देना था टेस्ट देना फाइनल बस वॉशरूम अभी टेस्ट को भी देख रहा है क्या ये वो परमानेंट व्हाटएवर उसके ऊपर अच्छा सोचिए क्या मुझे लगता है क्लास में पढ़ रहे थे बाहर जाना चलो ठीक है बेशक बहुत बाहर ही ना बाहर में बेचारा क्लास में मैंने यूट्यूब देखा मम्मी ने 12 बजे वीडियो बना देखा हम लोग को 4 मिनट तक बोला अरे 24 मिनट सिस्टर गलती से मेरी गलती है
This is it? Okay, let's start. So we are having like the meeting after what? 3-4 weeks? When is the last time you met? Have you written the date on the lecture?
14th December.
So after 2 weeks almost. What was the topic we were discussing? Sound. Last topic in sound.
Loudness.
Huh?
Loudness.
Loudness. Characteristics of sound. Okay. Okay. So I think the basics we have already done. So we were doing characteristics of sound. So, do you remember what are the 3 characteristics of sound? So, first is loudness, second is pitch, third is quality. So, why do we need characteristics? Like using these characteristics, okay, these are needed to distinguish between one sound wave from other. Okay, so you can differentiate between different sounds basis these properties or characteristics. So, what does loudness depends on? Did we discuss it? Depends on the amplitude of sound. Okay, it depends on amplitude of sound. Okay, so suppose you have a wave like this. Okay, this is, let us say, the amplitude. You have another wave. Almost double the amplitude. This is 2A. Okay, so the intensity is the measure of the loudness of sound, right? Intensity is the measure of loudness of sound. How is intensity defined? Intensity is defined as sound energy. Okay. So intensity in general, it could be for any energy. Okay. So I'm just writing energy. In this case, it is sound energy. Sound energy flowing per unit area. Like let's say this is 1 meter by 1 meter. So how much sound energy is flowing through this area in each second? Okay. Sound energy per unit area per unit time. This is how the intensity, right? Intensity is defined. Okay, because loudness is, it depends on hearing perception. The same sound, one person with a better ear, okay, might find it very loud, and the other person with a less sensitive ear may say that it's not so loud. Like it happens in case of music. The pop music or rock music, the youth likes it very much and they seem to enjoy it. At the same time, if there is an old guy, okay, he will feel like, what noise is this? So that is from hearing perception. So, but this is also called as objective quantity. There's anything which can be exactly measured is termed as objective. Okay. Whereas loudness is called as subjective property. Since it depends on hearing sensitivity. Of the listener. Okay. So if there is any sound, it will exactly have some intensity, but loudness will be experienced with. People may say, "Oh, this is not so loud for me." Other may say it is loud, like that. So this is objective property, which is exact property. Now let's define what is pitch. So first you write this down, then I describe what is pitch. Did you get the attendance? So what is the example of loud sound? See, if you're speaking softly, okay, versus when you're shouting, right? So your friends will come to know that it is the same person speaking, right? The sound does not change. What changes is, in one sound, the energy is more, and the other has less energy. That's what is loudness. So if the sound has a bigger amplitude, that means it is actually going with more energy. Now next, pitch. So what is pitch? So it depends on frequency. Frequency of sound. Okay. So the graph of this sound wave will appear like this. Let us say you have so amplitude is same. So how many cycles you see here? 2 cycles. Say at this time you have 2 cycles. 2 cycles. Now how many cycles? 1, 2, 3, 4 cycles. Okay. So what has changed here? Frequency. It has got doubled. The time period is half. So frequency is doubled. Is there any change in the amplitude? No. So it may happen that you may have a sound of same loudness but different frequency. Okay? So how do we differentiate? Like, can I speak in different frequency? The sound to me is unique to me, right? Whenever I speak normally, okay, you will come to know that which person XYZ who is speaking, right? Your family members, your friends, you would just know by listening. You don't need to see them. You'll understand who is speaking. So every object has a unique frequency. But if I'm speaking normally, but now I start speaking like this, what has happened? The vocal cord has been oscillated more number of times. Okay? So generally, a male voice has less frequency. Less frequency. So when some singers start singing on a high pitch or high frequency, high note, the sound changes. Like Nusrat Fateh Ali Khan, he really sings at a very high pitch. Okay? So, or Michael Jackson, when he, after finishing the line, in the end he did, oh! So that's high note. Okay? So normal is less frequency, but high will be like this. Female. So female voice has high pitch, has low pitch. Less frequency is low pitch. Hence, flat voice. It is also called flat voice. Flat voice. So female voice has high pitch. Okay. So sometimes the high pitch sound may be very piercing to ears. Okay. Ears. So male fighting versus females fighting among themselves. Can you see? So there you are. Male is like mostly less of speaking, more of punches. So that's what it is. So in musical instrument, what instruments will have low frequency? So there is a category like bass, right? Bass or bass, what do you call it? You have bass guitar, and then you have what? Lead guitar or rhythm guitar. So bass is that, or percussions. So you in tabla, everybody is familiar with tabla. So you have two, one with a bigger diameter and one with a smaller. So bigger one has less frequency. It sounds dub 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 like that. But the other one, there is a sharp tone. Okay, so that is high frequency. So that's bass. And high frequency sounds are called treble. Treble. Right. So in your music system, you have these adjustments. You can adjust the song for bass or high treble. So people have different preferences. Okay. Some like high bass, some like high treble. Treble or terrible? No, not terrible. Treble. Just check with that. Okay. Too much treble will become terrible. Okay. So here you can have like flute and trumpets. These will have very high frequency. Okay. That's it. And What is quality? Now there may be sounds with same level of loudness and pitch. Two sounds, similar, same level of loudness and pitch, but yet they may sound different. So let's see what are those kind of sounds. So quality of sound. Depends on the source of sound. Yeah. Quality of sound depends on the source of sound. So what is it? Like two friends speaking, right? When a conversation is happening, so both of you are talking at the same level, same sound level. Okay? And nobody is speaking too fast or too slow, so frequency also same. Yet the sounds are different because different vocal cords, right? So in the case of musical instrument, when the orchestra or the music is composed, there are so many instruments. But to play in harmony, to maintain the harmony, everybody has to maintain the same level of loudness and frequency, right? So nobody is going ahead of others. So everybody play in harmony. So there the quality of sound is different. So a flute will sound different, although at the same loudness and pitch, and some other instrument will sound different. So what is different here is the waveform. Let's say you have a waveform like this. One waveform is like this. So the this time. And here the waveform is like this. So one cycle in the same time, so frequency same and same level, same amplitude. But yet the sound will be recognized differently. Okay, same time to complete one cycle, both, but their waveforms are different. So sound produced by different sources. Okay. So again, pitch is a subjective property. What is the objective property? Frequency. Okay. So two sound with different pitch. Experience wise, some ears are sensitive to certain frequency. So some person may find some high pitch sound as not so high pitch because his ears are not tuned to it. Okay. So pitch is a subjective, experience based property, whereas frequency is objective property. Okay, I forgot to tell you the unit of intensity. So, write down unit of intensity. Can you tell me what will be unit of intensity? Look at the formula and tell. What shall be the unit of intensity? So these are like pleasant sound. So quality wise, pleasant sound would have rich quality. Okay? It will be like you would love to to hear it as much as the sound is played, rich in quality. It will be harmonious, whereas unpleasant sound is low, as low quality. Very low quality. And is termed as noise. Okay, that's all. Intensity. What is its unit? See the formula and replace with units of individual quantities in the formula. Yes, Rishka. What is unit of energy? Joule. Unit of area? Meter square. Unit of time? Don't tell me you didn't know the units of this. This is the unit of intensity. Okay, so you will write joules per meter square per second. Or you can write joules per second per meter square. And what is joules per second? Unit of what is energy upon time? Power, isn't it? So what is joules per second? Watt per meter square. So intensity can be defined in two ways. It is defined as the rate of energy flowing. So it is rate of energy. So joules per second. Rate of energy flowing per unit area. Okay. Rate of energy flowing per unit area. Or it is power flowing per unit area. Okay. So anything. So you can say rate of energy flowing per unit area. Right? Either which one. So you can write the units. Next is, then there are some terms like with music, you come across terms like tone and note. Okay, what is a tone? Tone is a sound of unique frequency. It is a sound wave of unique frequency. Okay, just one frequency. Whereas note consists of mixture of frequencies, like a musical note. It consists of mixture of frequencies. Like we have a musical octave. Have you heard about it? Sa, re, ga, ma, pa, dha, ni, sa. So these are different sounds. Together forms one note or one octave. 8. Okay? So that's a note. Alright. So you can actually, once you understand all this, right, and learn a little bit of musical language, you can write the songs on paper. Then you can actually play it. Okay. That is what they teach in School of Music. Right. The other side is. Okay, so let's go further. Next is speed of sound in different media. Are we good till here? Okay. Now, what is the speed of sound? Did I tell you speed of sound? Huh? It is different in different mediums. Speed of sound wave. Can sound wave travel without a medium? No, because it is a mechanical wave, right? It is different in different mediums. Its speed is highest in solid medium. Highest in solid medium. Okay. Lowest in gaseous medium. And in between solid and for the liquid. Okay, so you can say Vs is greater than Vl is greater than Vg. Okay. S for solid, L for liquid, G for gas. So, for example, you can have speed of sound in steel. Steel is solid, will be greater than speed of sound in water. Water. This will be greater than speed of sound in air. Okay, so this is how it is, and there is a table given in your notes. So all these sounds at 25 degrees are given to you. So in air, speed of particular significance is air. So that is the most familiar medium in which sound travels for us. Next is reflection of sound. So you're familiar with reflection of light. So what is light? Is it a wave? Light is a wave. What kind of wave is light? Electromagnetic wave. Just like light wave, sound wave also obeys laws of reflection. Just like light waves. Sound wave also obeys laws of reflection. Okay. So for example, if you have a wall of the room, wall. So you require a big surface. Like light can be reflected by even a very small glass because the size of light wave is very small as compared to sound wave. Okay, so sound wave size is very big actually. So let us say a sound wave is incident on the wall in this direction, right? So there is a illustration given in your book like this. Let's draw that. Suppose this board is a sound reflector. And I am a source of sound. I am speaking in this direction. So my sound is going here. So I am not looking towards you. I am speaking here. But the sound is reaching you. Okay? So if this is a board, so there is an experiment shown in your book. Let's say this is a table. Right? Here you are conducting the experiment. And this is some board you have kept vertically on the table like this. And here you have pipe. In front of which you have kept a ticking clock. So when the clock is ticking, it's making noise. And on the other side, let us say you are listening to the sound coming from the clock, right? So what you are doing is, this is the normal, right? So the sound wave must be traveling like this. Okay, this is the normal. And when you change the position of the pipe, at a certain angle, you hear the loudest sound. And when you draw it on the chart paper, you find that these two angles are equal. Okay, so this position of the pipe is changing on the table, like this. This is one direction. So here this is fixed, and the clock is kept here. Now while listening, let's say you are changing the orientation of the pipe. So at a particular angle, you get the maximum sound. And then when you draw the normal here, and measure the angles, you find both the angles are same. So this obeys law of reflection because angle of incidence is, therefore angle of incidence of the sound wave is equal to angle of reflection. And in the chart paper, the incident ray, the reflected sound wave, and the normal, they all lie on the same chart paper. So it obeys laws of reflection. Okay. So next is application of some applications. Of reflection of sound waves. So reflection of sound wave produces echo. Okay. So echo, what is echo? When the speaker hears his own sound, okay, after he is finished speaking, it repeats. So when the speaker uh, speaker listens or hears his own reflected sound distinctly. Yeah. Distinctly. He observes. Right? So, like I said, the sound wave can be reflected by walls, right? Or the cliff of a hill. Okay, it can be reflected by that. So why are we not hearing the echo here? Or don't we have walls here? Should be the natural question. So why are we not hearing the echo here? The reason is whenever we hear any sound, it remains in our ear for about 1/10 of the second. Sound persists in our ear for about 1/10 of the second. So if we have to hear the echo, the sound has to reach our ears after that time interval. It should reach at least 0.1 second later than the original sound ceases. Okay? So, since sound persists in the air for about 0.1 second, therefore, here distinct echo. Here echo. Echo means distinct sound. Here echo. The reflected sound must reach the listener at least after is at 0.1 second or after. This is the condition. So why in the room it's not taking 0.1 second? Because speed of sound is 300 plus meters in a second. So it can travel 300. So how many meters is this? Hardly 4 or 5. But it can travel 300 meters. In one tick, it has traveled 300 meters. Will anybody be able to listen to me standing 300 meters away? If I put in lot of energy, loudness, when I really shout, yes, they may. Right? But if I speak softly, the medium will absorb it because the energy, whatever energy I am producing by speaking, is disturbing the air particle. And these are oscillator. So my energy is transferred. But after some time, the medium has friction. It will die out. So my sound will not be able to disturb sufficient amount of air molecule to reach or travel higher distance. So it's like that. Okay. So this is echo. right? So what are the conditions for echo? When echo will be produced now? Condition for echo. So one condition is the reflected sound must reach must reach at or after 0.1 second. That's one condition. Second condition, the minimum distance of sound reflector should be about 17.2 meters away. From the source of sound. Okay, it should be able that much distance away from the source of sound, source of sound. So proof. So consider a sound reflector here. Imagine a person speaking here. So when he speaks, goes in this direction. Let us say the distance of the reflector is d. And then the reflected sound will be traveling back the same distance d. Okay? So the reflected sound also will travel same distance d. So what is the total distance traveled? So therefore, what is the speed now? D plus d by t. Right? Where t is the time of echo. Time for sound to go till the reflector and the reflected sound to come back to the listener. Then only he will hear the echo. Right? So what is the minimum distance? So therefore 2d must be equal to v into t, or v is equal to v into t by 2. Okay. So when you substitute the value, what will you get? The speed of sound is 344. Sometimes like it is given in 346 also, but in the textbook the calculation is done using 344. Time is 0.1 for echo, we said. So how much is this? 17.28. Okay. Any sound reflector is it 17.2 meters away in the room? Hardly 3-4 meters. That's why the original sound does not die and the reflected sound also reaches before that. So we are not hearing two different sounds. When I am speaking, I'm also able to hear what I am speaking. Okay? So with this, we are done with the sound demo. When is the class? When is the first break? 1 o'clock. We have 6 minutes. So we can do this numerical. And then when I come back, we'll do uses of multiple reflection of sound and then we close the chapter. Uses of multiple reflection of sound, then we have one more topic, range of hearing, and then uses of ultrasound. 3 topics are there. Okay, let's do the example. So is the concept of echo clear? Where are others? Are they traveling? Or is it exam? No idea. No idea. You are enjoying winter breaks, it seems. So read example. A person clapped his hands near a cliff and heard echo after 2 seconds. So time of echo is given. So this is example 2. So are you done writing or writing? ठीक है लिख लो. You understood no? Why D plus D? D for incident wave, another D for reflected wave. So total distance traveled by the sound wave is 2D. And this is a simple speed formula. Speed is distance upon time. If you don't understand this, you can write one more step. Since speed is equal to distance upon time, the total distance is 2D and D is time of echo. Right? So we know this formula, that's why I've written correctly. So be careful, wherever you have a question, numerical question on involving echo, the formula is this. You will always have to use 2D, not just D. Speed is not distance upon time. Speed is twice the distance upon time. That's what you have to do. Okay, so now we have a cliff. This is a hill, cliff, whatever. And a person claps it. Okay, it's clapping. So obviously he will hear to his own. So D, right? So what you have to find out? What is the given? Given is time of echo. Given. E is equal to how much? 2 seconds. Time of echo. What else is given? This is 2 seconds, not 25. 2 seconds. Then you have what is the distance of the clip from the person? The speed of sound is taken as 346. Speed of sound is equal to 346 meter per second. So distance of the clip. Is equal to 1. So it's an echo problem. So this problem, right? Is equal to so it's same 346 meter. So it's simple when you understand the concept in volume there. Like first calculated double the distance and all, that's not required. You save time doing this. Okay, so I'll see you after the break.